Mhm. Hey guys, good evening all of you. Can you hear me?
Hello, good evening.
Hey, good evening, buddy. Mm. Hey, I'm sorry for last this weekend class, right? I was quite busy with my schedule. Okay, so minute, so, mm, mm, okay, right. So we have done with the the basic Spanish tree concept, right? So we have covered all the part of the configuration BPD that is used to the if I talk about the BPD parts. So BPD is a bridge protocol data unit, it's a layer 2 protocol, right? It's a layer 2 protocol, and that is going to exchange the switch ID information. Right? They have lots of information that if I talk about the port ID, the cost, right, and the sender bridge ID, who is the root bridge information, what is the port ID information, everything is present in the BPD packet. So the BPD basically have divided into two types. If I talk about the BPD configuration BPD we have, right, that is going to use to configure the loop free topology, right, and at the same time we have another type of BPD that's called as a TCN BPD, topology change notification. So the BPD has categorized in the two ways. One is the configuration BPD used to configure the loop free topology, and one we have a TCN BPD that's called the topology change notification. Right. On this BPD will be exchanged on the multicast address, right? As we know that the destination source will be unicast MAC address, and destination will be, of course, multicast MAC address. The reason is to put the multicast MAC address is that we don't know, we don't the switches is not aware, right? Switches is not aware about the destination part. That's why they are going to use the multicast MAC address. And this BPD will exchange at every 2 seconds, right? You can manipulate this timer as well. It's totally up to you. But yeah, this is the default behavior. And it's never recommendation to not we can sort of never recommendation. If you change the BPD timer, so you have to first see your topology, right? Depend on the topology, how big network you have and how small network you have. Based on that, you need to modify the BPD timers or any spanning tree timers, right? Like we have a listening and learning state, right? We have maxes. These are the timers. The spanning tree timer is totally depend, right? Is depend on the topology. So if you want to change the timer, right, you have to see how much topology you have. If you have a big network, you can change. If you have a small network, you can change it, right? It's not like that. Okay, we have a normal scenario and we can change the timers over there, because to changing the timer in the spanning tree protocol, it will affect on the many things. So till this point, what a BPD we have covered? We have covered just this BPD configuration BPD to configure the topology. Then what is the role of TCN BPD over there? What is the role of TCN BPD? See, this is your stable network, right? Take example, switch 1, switch 2, switch 3, right? This interface we have 0/0. Understand this part. This is the little bit logical one, but yeah, it's easy, not hard. 0/0, 0/1, 0/0, 0/1. Okay, so this is my fixed topology we have right now. So we have this guy's a DP port. We can assume, right? This is the DP. This is a DP. This is the RP. This is the RP. This is a DP, and this is the blocking. And right now we have some host over there. I take example. So these are the hosts that wants to communicate with the, right, like this to like this. Switch 2 we have, switch 3 we have, and if the PC1 wants to communicate with the PC number 2, right? Sorry, if the PC1 wants to communicate with the 2, what path they will follow? Of course, they will follow this path, right? The MAC address, if I'm going to write on this guy, so we have IP will be this person will be IP will be 10101, and MAC will be what, A, right? Same thing. If I'm going to talk about this person now, we have IP will be 2, B, MAC IP will be 2 over there, and this is the 0/2 interfaces. Guys, this is the understand this part is very, very important, and this help you, right, in the future as well as, right? Because you know, if you go for the data center network, right? If I talk about the data center perspective, right? We don't have a spanning tree. There is a spanning tree is there, right? But we are removing this spanning tree protocol over there. The reason is many reasons, suboptimal path, and basically we are not using the right. Basically, what a spanning tree is doing over there, it's preventing the loop on the layer 2 network. But if you think in the beyond the design perspective level, a spanning tree is not good for the network, right? So now understand one thing why this is not good. I'll tell you through a little bit deep level. Okay, see, if this person PC1 wants to communicate with the PC number 2, I can directly go by this path as well, right? But which path I'm taking? Suboptimal path. I'm just giving the one disadvantage. If somebody will ask you, hey, tell me what is the risk, because every person is what asking. They're asking, hey, what is the advantage of the spanning tree protocol? A very less person is going to ask, hey, tell me what is the disadvantage of the spanning tree protocol. And people are saying there's no disadvantage because it's preventing the loop, right? Of course, there's no disadvantage, but there is. Can you see that? Suboptimal path. I cannot go by like this, right? Because this is the blocking port. Second thing, wastage of resources. Can I utilize this particular link for data traffic? No. So these are the two biggest disadvantages of this spanning tree protocol. These are the biggest disadvantage of the spanning tree protocol. Now understand one thing about it. Okay, that's my, I'll just write on a small letter. Spanning tree disadvantage. Okay, don't tell in the interview until unless they are not asking for you. Okay, suboptimal routing, not routing, optimal path. And then we have a we can't do load balancing. Jokes apart, leave it. Okay, now understand the concept of thing. Right now, this is my what? This is my stable network. This is what? This is my stable network. We have a two types of topology. If I talk about the topology part, we have two types of topology. One we have a in the current network, right? In the current network, we have two types of topology. One we have a stable topology, and one we have is unstable. I'm talking about after the configuration. Stable means what? Everything is so far good, awesome, fantastic, amazing, bingo. That's the meaning of a stable topology. Everything is good. What is the meaning of unstable topology? Path is change. Sometimes my packet will go via path 1 and sometimes path 2. That's the meaning of unstable. Stable means what? Path is remain same for all traffic. So right now, this is my stable topology, right? So like this is my if I talk about the logical one, right? Logical topology of this person, how the logical topology look like this, switch 1, switch 2, and switch 3. This is my logical topology, right? Right now, this is my logical topology. But what happened? Take example, if one of the link goes down, right? Take example of this link. Now what happened? This will comes in the forwarding state. So now your topology is moving to the stable to the unstable. This was stable and it will move in the unstable state, right? Again, if this link comes up, right? Take example. Again, if this link comes up, what happened? It will move in the this topology, this section, right? So can you see that what's happening over there? Every time if your link goes down, right? If this link goes down, this will comes in the forwarding state. And if this link comes up, automatically what happens? This will move in the blocking state. Again, if this link goes down, what happened? This link will comes in the forwarding state, right? And if this link comes up, what happened? This will move in the blocking state. So your topology can move from stable to the unstable, here to here. Right now, I'm not going to tell you it's a bad. You have to decide. Okay, is it bad or good? See, if I talk about the according to the process perspective, right? According to the the resource perspective. 1 minute. Let me put it down over there. If I talk about the resources perspective, right? changing the topology. Right? So you may say that, okay, of course, law, we have a good amount of CPU. You may say that, okay, of course, we have a good amount of CPU that will not create a big issues. Right? And I'm agree, right? Because of course, if you're implementing the spanning tree protocol in your network, you have a good amount of, right, the CPU and everything. But now understand the perspective of flow. Now understand the perspective of flow. I'll tell you, I'll first show you this perspective, right? And then I'll come to the flow as well as. Right now, understand if this person wants to communicate with this guy, right? If this person wants to communicate with this guy, how the traffic flow will happen like this. Return traffic also coming like this, because this is the blocking state. Oh, sorry. Come on. So if I talk about the MAC address table of the switch to, right, of course, this guy will generate the ARP request. First of all, A, source MAC address destination will be FFF, right? So what is the MAC address table of the switch to now? If I talk about the switch to MAC address table, we have a 0/2 on this particular interface. The MAC will be A. It will send the packet to home. Switch 1. Switch will learn the MAC address on a 0/0. MAC will be A. Now it will forward the packet to this guy. Switch 3 will learn this interface 0/1. MAC will be what? A. It will send the packet to the PCB. PCB will create the reply packet. The B will be source and destination will be A. Some packet is coming over there. Now the 0/2 interface MAC will be B. Send the packet to this guy. What happened? Now on the 0/1 interface, I'm going to learn the MAC address of what? B. And now I'll send the packet to this guy, right? On this interface 0/0, I'm going to learn the MAC address what? B. And now it will send the packet to this guy. Now it will send the ICMP request packet. ICMP request packet have a source MAC address B, A, and destination B, ICMP, right? I'm not going to write the IP configuration. Understand this part, guys. Packet is coming to the switch 2. Switch 2 will look up the MAC table. Destination is V. Yes, 0/0. I need to forward the packet to this guy. Switch 1 will receive the packet. Sorry, frame. And you will see the frame has a destination MAC is B. B is associated with the 0/1 interface. And switch 3, same thing is going to do. Reply like this. Everything is working fine, right? Everything. But have a look now. This is my this is my MAC address table of the every switches, right? And this MAC address table is valid for how many second? 300 second, 300 second, and 300 second. That is known as a MAC aging time. And as we know that if you don't have a MAC address information in your MAC address table, then switches will do the unknown unicast flooding, right? If switch does not have MAC address information in MAC table, then it perform unknown unicast flooding. That's a behavior of the switches. Now understand this point. What happens if this link goes down? What happens if this link goes down? So how will your logical topology will happen over there? Your logical topology now will be changed like this. Right? Because this will move in the forwarding state now. How much time? Okay, forget the time right now. Forget this time right now. Understand this case now. When this person will send the packet, source packet is A, destination packet is B. When this packet is coming to the PC1, PC1 will send the packet to the switch 2, right? What switch 2 will do in this case? Switch 2 will look up the destination MAC. And what's the destination MAC is saying that, hey, my destination MAC is what? B. And B is associated with the which interface? Where should I forward the packet? What switch 1 will do? Switch 1 receive the, hey, what is the destination MAC? B. Where should I forward the packet? 0/1 interface. Do we have a 0/1 interface? No. If this interface goes down, will it appear in the interface? If the interface is not available? No. This is down, right? So what happened? Whatever the amount of packet this guy is sending, like take example of 1000 packet this guy is sending, all this 1000 packet will be dropped on this guy. What PC is assuming? Hey, I'm sending my traffic. What PC is assuming? Hey, I'm sending my traffic. Hey, I'm sending my traffic, but I don't know in between who is the guy, who is the responsible person is dropping the packet. Because I'm not getting the reply, right? Reply in the sense of what? Whenever you're typing the google.com, right? Have a look. When you type the google.com, normally what happened? You will get the result, right? The space. So it means that you're sending the request and Google is giving the reply. Same thing. What happened over there? Am I getting the reply over there? No. So what I'm understanding, hey, I'm sending you something, but someone in the middle of between me and the another side is dropping the packet. Who is the culprit over there? This is called what? This is called as a black hole. Isn't it? This is called as a black hole, the traffic, right? Someone is dropping the packet. I don't know. And why this thing is happening? This thing is happening. This black hole is happening just because of what? MAC address table has not been updated by such. Because what a spanning tree is doing, this guy saying, hey, I'm the spanning tree protocol. What's my responsibility? If this link goes down, I need to put this interface in the which state? Forwarding state, right? Maybe the RP and DP, of course. Of course, this interface will move in the, this is the switch one is the root bridge still, this is the DPRP and DPRP, right? Forwarding state. How long it will take? How amount of time the switch 3 or we can say the spanning tree protocol is required to put this port into the forwarding state? I'll let you know right now. Sometime it will take the 30 second. Sometime it will take the 50 second, right? Hypothetically. I'll let you know in which scenario it will take the 30 second and 50 second. I don't want to discuss right now. Yes, but yeah, we have a two types of time. I don't want to make a confused guy right now. We'll see in which scenario we will take the 30 second or in which scenario it will take the 50 second. But yes, right now it will take the any of the time. So my spanning tree, we can say that, right? My spanning tree is faster than MAC address aging time. Is it? Guys, pay attention. Don't you think so? My MAC aging time is what? 300 seconds, right? So my spanning tree is faster. My spanning tree said, hey, I will put this interface into the forwarding state just 30 seconds, right? Or maybe 50 seconds. Overall, if I talk about the hypothetically, we can see the 1 minute. Of course, it will not take the 1 minute. 50 seconds. It's a huge difference between the 1 minute to the 50 second, right? Hypothetically. And hypothetically, MAC address 5 minutes. See the difference. And why this thing is happening? Because switches has not been updated. The MAC address table. But whereas the spanning tree protocol has updated, has been updated the interface status in the case of a spanning tree protocol, right? So till 5 minutes, what happened, guys? Think about it. Till 5 minutes, your packet will be black hole drop. Because after the 5 minutes, my MAC address table will be updated. This problem is happening. All good? Law is ISIS class going on. Who's the guy? This is Fayaz. Can you join me? ISIS traveling. I missed some classes. Classes will be tomorrow. 8 p.m. Sorry. Yep. Let's go, guys. This problem is happening, right? And why this thing is happening? Because switches has not been updated the MAC address table, right? Whereas the spanning tree protocol has been updated the interface status. And this is, we can say that hypothetically, the spanning tree, not hypothetically, even right, the spanning tree protocol is faster than the MAC address table, right? In this case. So for the 5 minutes, all my traffic will be dropped. Why this thing is happening? My stable topology is now moving into the unstable or unstable to the stable, stable to the unstable, unstable to the stable. This process will go on. So what we have to do over there, what we need to bring over there, we need to call the one guy, and that guy name is what? TCN. Spanning tree protocol, TCN BPDU. What this guy is going to do? This guy. 1 minute, guys. Just give me 1 minute. All good? Sorry. What we have introduced, guys, over there, we have introduced the concept of TCN BPD, and this is the happy guy, right? What this guy is going to tell you, hey, let's do one thing. As the name suggests, that is the TCN BPD. TCN means what? Topology change notification, right? If something had changed in my network, if anything changed, and what is the role of this video? Of course, if something will change, I need to generate. That's the meaning of notification, right? Topology change notification. I need to notify, right? What this guy is going to do, switch is going to notify, hey, something has changed in my network. And what is the role of this guy? To convert in a very simple way. To convert the MAC address using time 300 second to the forward delay timer. And that is 15 second, right? All good. So what happened whenever, right, non-root bridge feels, hey, something has changed in my network. Non-root bridge will send a TCN BPDU from its root port, that is called as a RP, right, towards the root bridge switch. Once the upstream switch, right, receive the TCN BPDU, it will give TCN acknowledge. TCN BPDU is reliable, right? I need to acknowledge of them. After reaching, right, root bridge will set the TC bit in configuration BPDU, right? And it will flood to the all non-root bridge. And based on this TC bit, all the non-root bridge switches, right? All the non-root bridge switches will convert their MAC address table aging time from 300 second to the forward delay. So within a 15 second, my this table, right, has been updated. Which table? This forward delay, this MAC aging table, MAC address aging table. So this is the role of TCN. This is the reason why we have introduced the TCN, right? So in that case, what happened? We don't have any black hole in my network. No drop will be happen for the 5 minutes. Within a minute, I'm going to converge all the network volume. Have a look. Sorry. Okay, another thing. Your TCN BPDU is an empty packet. They don't have any information. As compared to the configuration BPDU, the TCN does not have much info. If you have a look over there, I'll do one thing. Start this devices. All good. Meanwhile, I'll just show you read this line, and you can see that this is the information that is put in the TCN, right? So protocol ID that always set to the 0. So 2 byte number version is always 0 in the the PBST protocol, and the message type will be configuration TCN BPD over there, right? That's a 1 1, right? So we can say that the size of the TCN BPD is a 4 bytes. If I'm not wrong, it's a 35 byte is the configuration BPD. If you have a look, the configuration BPD has a lots of information, right? Yep, this one. So we can say that configuration video has a lots of protocol ID, version, message type, flag, root bridge, root path cost. So 2 byte, 2, 3, 4, 5, 5, 8. It will be 13 and 13 plus 4, 17 bytes. And then we have a 17 or 8. It will become the 25. Is it? Yeah, 25. Then 2, 3, 3, 3, 3, sorry, 35 bytes. So they have a lots of information. That's a configuration video, huge information. But in the time as compared to the TCN BPDO, TCN does not have much information. They just have a basic information, what kind of version we are going to use, what kind of packet we have. That's it. And which protocol I'm belonging to, the PBST or RSTP or MSTP. So just a 4 byte as compared to the 30 byte, right? They just have basic information. That's why we are saying that this is the empty packet, because that's compared to the configuration, they have a huge amount of information. And what this guy is going to do, come on, wake up. If you see a topology change occur whenever switch either move the port from the forwarding state or move a port from the forwarding state to the listening learning into the blocking state. It means that a port 0/0 will move in the forwarding state. It will join the TCN. A port 0/0 move in the blocking state. It will join the TCN. Let's prove this thing first of all, right? Then we'll go on the next line. That will be a good way to understand each and everything. So let me check what is the port size. Okay, it has to be 40. All good. Switch to switch one. I think so. Everything is good now. Switch two, switch three, switch one, switch five, switch six. Switch off. Okay, all good. I'll just, first name switch two. See this information. Leave it. First name switch three. All done. Switch one, switch five. That's it, right? Awesome. Okay. And here we have, I'll enable some kind of debug over the debug spanning tree events, right? Better to do one thing now. I'll just write on in the notepad and do the copy paste and okay, do it over there. Awesome. Checking the domain name. Meanwhile, I'll do one thing. I'll show you one thing on a sys2. If you see, I just say this person, right? Interface gig0/2. That's this guy, right? I told you that the interface will move in the blocking or forwarding. It has to generate the TCN, right? Shutdown. Come on. Interface goes down. Okay, I need to do one thing. I forget anyone one thing. One minute. PVST. Done. Sys2. Oh, come on. Right now, no need to see that one. Okay, have a look. If I just going to show you the interface, any of the interface, I can, as well as I'll capture this thing as well as like, I'll make this guy switch one should be is mode, not mode. VLAN amount priority will be. Just right now, I'm trying to show you this behavior, right? This first line, right? Nothing else. So I'll make this guy the switch one is the root bridge right now. This is the root bridge. And all these guys are non-root bridge. Everyone is non-root bridge. And I'll capture this link as well as, and this link as well as. You can see that right now topology change is happening. Wait for some more time. I'll show you something else. Better to I'll read. Meanwhile, I'll open to the VMware as well as. Come on. And I'll, you know, can you see once I put this shutdown interface, what happened? It will generate a topology change notification, right? All good. At the same time, right? Once I down this interface, it will generate TCN, and if I'm going to up this interface, it will send the TCN. Wait for some time. It's a listening state right now. Once it will move in the forwarding state, it will send the TCN. So moving in the blocking, it will send the TCN, and moving in the forwarding, it will generate the TCN over there. That's the point I want to show you guys. Learning. Can you see that TCN generated? Why? Forwarding state. So hope this line is clear to you guys. Like whenever I'm not able to take the screenshot as well as. So I'll just copy this guy and put it in the paint file. Whenever, like your code will move in the blocking state, right? Interface change to start up, and this is the down. Where is down? Right? Down is not showing that. So that this is the guy from here to here. Okay, and you can see that once the interface are down, done, and when the interface nodes are done, forwarding state, I mean say that. So interface move in the shutdown and forwarding state, it will generate TCN. This is the first line that I want to prove you guys. This first line. Hope this thing is clear to all of you. When the TCN will be generated. Topology change. Now, in other words, a port and active switch comes up or down. Simple language. Bouncing the interface. Simple language, bouncing the interface. Flap the interface. In two cases, we have a TCN will be generated there. I just want to see, this is a very short topic. I can explain you the TCN in just a 10 minutes as well as. I just want to clear all the concept. That's why it's taking so much time. Otherwise, I can give you the just a 10 minutes explanation. This is good, right? Understand next line. The switch send a TCN, right? This line. It's from the root port, RP. Ultimately, the root bridge received the news of the topology change. Notice that the TCN BB2 carry the no data information that I told you that it's an empty packet, but it informs the recipient only that the change has occurred. Also notice that the switch will, okay, forget this line right now. The switch continues sending the TCN BB2 every hello timer at 2 seconds until it's get an acknowledged from the upstream neighbor. As the upstream neighbor receive the TCN BB2, they propagate it on towards the root bridge. So at the end of the day, what happened? Every non-root bridge switches send this information to the root bridge and send their acknowledge. Once the root bridge receive the TCN BPDU, it also send the acknowledge. But however, the root bridge set the TC bit, right? Topology change flag. In which BPDU? Configuration BPDU. The change caused all the bridge, the switches shorten their bridge table aging time. That's a MAC address table from 300 second to the forward delay 15 second. तो वहां तुम्हारे 300 सेकंड से कितने आ जाएंगे 15 सेकंड में. This condition cause the learned location of the MAC address to the to be flushed out much sooner than they normally would, easing the bridge table corruption that might occur because of the change in the topology. However, any station that are actively communicating during this time are kept into the bridging table. This condition lasts for the sum of the forward delay and max time. That's a 20-second over there. So this condition will be happen, right? This learning process will happen till 35 seconds over there. After that, what happened? Okay, leave this one. That's not important so far. So whenever something will happen in a simple language, take example. Someone mic is on, guys. Right now, okay. Uh, uh, let's take example. I'll take a screenshot of this guy, and I'll paste it over there. When this link goes down, take example. Okay, before that, I'll say that this is the DP, RP, DP, RP, DP, RP, DP, RP, DP, RP. Whenever this link goes down, what happened? Understand now this concept. This guy will send the TCN. It will give the acknowledge. This guy will send the TCN. It will give the acknowledge. This guy will send the TCN, and it will give the acknowledge. This guy will send the TCN to this guy. Now, it will give the acknowledge, but at the same time, what happened? They will set the TC bit and TC acknowledge. Normally, what happened? He's giving the TCN, and he's giving the TCA, acknowledge, TCN and acknowledge, TCN and acknowledge, and TCN. What happened? He will give the topology change TC flag on and TC acknowledge. This is the flag. What this guy is going to do? This guy will convert the 300-second MAC address aging time into the 15-second, right? And this process, right? All this thing is happening till 35 seconds. Total 20 seconds is your max is time plus 15 seconds your forward delay. So within a 15 seconds, your MAC address table has been updated by the switch just because of the TCM. Have a look. If you see, I'm just going to shut down this link, right? This particular link, and you can see that interface gig 0 slash, right? Or maybe on a switch 5, I'll say that this guy, right? In gig 0 slash 1, shut down. What happened? What is the MAC address of this interface? First, to write on the MAC address of this interface so that we can easily identify. Right? And what is the MAC address of the switch 1? This interface, so that we can see that he's sending the TC flag. Right? And now, good. Shut down. After this interface now, this is link, this particular link, and now you can see that not this one, TC generated, and who is the guy generated? At the same time, also this capture this link as well as 21 TC root. I'll receive it, and I will send the TC flag. Stop this guy, and stop this guy. You can see that, right? Switch 5, this interface goes down, this particular link, right? This particular link goes down, right? This one. What happened? Switch 5, this interface. Is it 81.0.0 CB? Guys, I cannot write down right now because I have something written over there. That's why I'm not going to write anything, right? Or leave it now. You can see that from, this interface. MAC address. He's sending the TCN to this guy. And there's no, you can see that this BPD is called as a TCN BPD. Normally we have a configuration, right? So if you compare with the configuration BPD, I'll just show you any configuration BPD. Okay, I'll take a capture of the configuration. This is a configuration BPD. So can you see that as compared to the configuration and TCN, there are lots of differences happening. TCN does not have any information, right? They don't have it, but configuration, they have a lots of information. Configuration BPD, TCN BPD. So configuration has a lots of information, TCN does not have. TCN is just going to tell you something has changed in my network. So once this guy will send the TCN to this guy, right? What happened? It will give the acknowledge. See, switch for. Check the switch for MAC address table of this guy, or MAC address of this interface. Sorry. Sorry. Come on. Good. 2T01, right? And you can see that this guy person should send the, the TCN acknowledge. Open the capture between the switch 4 and 5, right? So this is the guy that I want to look up. 2T01, right? And you can see that this is the which BPD we have, configuration BPD, and this configuration BPD, what happened? I'll better to do one thing. I'll capture this one, and so no, you can understand in a better way. So I'll show you. I'll capture this link, and I'll put it into my Paint, so you can analyze each and everything in the one page. That's amazing. Come on, why are you not working? Sometimes my snipping tool is it's not great. All good. Paint. I don't go space. Oh. Okay, so this TCN BPD, and if I talk about the acknowledge, so you can see this is my acknowledge. This is the TC change, and my neighbor is giving the I think so this one. Yep. So now let's new, and here we have. So this is the acknowledge one. So he's sending the TCN and he's giving the acknowledge. So acknowledge is not a separate packet. Still, I'm going to use the configuration video. It's just a flag. Acknowledge is just a flag of the configuration video. Acknowledge is just a flag of the configuration video. The flag is one, it's going to represent a yes or because the on. And now, once this person, right? So this point is clear. He's giving the acknowledge, acknowledge, acknowledge. And what this guy will do now, see this behavior. Once this guy's in a TCN, it will send a TC bit plus acknowledge bit. Both are on. So come to the switch one now. It has received the neighbor from EUF, and I have to open this guy now. And here we have a magic new, and come on, and here we have. Can you see that? This is the information that is coming from the root bridge. This is the information that is coming from the non-root bridge. This is the information non-notification. And you can see the still type is configuration BPDO, and here we have a BPDO flag that we have a both are on TC, acknowledge, and TC. Topology. This is the flag, right? This is the responsible flag. You say, hey, let me convert 300 second to the 15 second forward delay. This information will be flooded throughout all the network. So if you see that once this person, right, will send the give the TC plus acknowledge, now this person will flood this info to this guy, this guy, this guy for how many seconds? Till 35 seconds, right? So if you see, even if you have a look over there, right, switch 4 is informing the MAC address 2D01, right? Can you see that 2D01? Yep, he's sending the TC bit as well as. Yeah, of course, right? Topology change. So like this, he's saying the TC now, and TC now. He's giving the acknowledge of this TCN, right? And after that, this guy is giving the TC only. And this is the guy that's going to convert the 300 second to the 15 second forward delay. Guys, here I'm done. Let me know if you have any questions, right? In the TCN part. I'm not done with the complete TCN. Yeah, the overview of the TCN, I'm done. We have something more about the 2 hour. Let me know if you have any questions till this point. Or should I move? Okay, perfect, man. So guys, now if I talk about, so we have seen that we have two types of BPDU. One, we have a configuration BPDU, and one we have a topology change BPDU, right? TCN. And TCN is does not have any content, kind of any information, right? They are just going to convert your MAC address table aging time 300 to the 1500 second. But the TCN BPDU, right? If I talk about this person, it will generate it. So it generates the TCN BPDU in the 3 ways, or we can 3 manner, we can say, not the 3 ways. Smart looks good. 3 manner. 3 circumstances, you can see that. One, we have a direct. First, make the insignificant. If I'm not wrong with my spelling is correct, right? Insignificant topology change. If the spelling is mistake, just understand insignificant. Okay. Then we have a direct. And then we have a indirect. We have 3 circumstances in your network, right? Where you have a changes happen. 3 changes. Change 1, change 2, change 3. देखो, if I talk about the insignificant, कोई मतलब ही नहीं. Insignificant means what? वो तुम्हारे नेटवर्क में कोई प्रॉब्लम नहीं कर रहा है, but they are generating the TCN. Insignificant means what? There's no significant, right? That's not going to affect on your network. This guy is not going to affect your topology. But it convert, or we can reduce 300 second to the 15 second. Unnecessary. That's the meaning of insignificant. For example, मुझे बताओ एक चीज, अगर मेरा ये इंटरफेस, if this interface goes down or up, is there any effect will happen in my topology? क्या मेरा ये लिंक ब्लॉक होगी, आप आ जाएगा? क्या मेरा ये लिंक ब्लॉक होगी, ये आप आ जाएगा? No. If this link goes down or up, right? If this link goes down or up, if the host is going to power on the switches, sorry, if the host is going to power on the laptop, and if the host is going to power off the laptop, will it affect on your current topology? No, that is called as a insignificant. That there is no significance, right? This guy is not going to affect in my current topology. But again, the problem is what, guys? If this link goes down, it has to generate the TCN, right? It will generate TCN, right? That will convert your MAC address aging time 300 seconds to the 15 second, right? So ये तो problem कर रहा है ना यार, CPU तो high, that will increase the CPU process. That will increase the CPU process. Understood? To avoid this problem, what we can do over there, we are going to enable the one feature that is called as a port fast. And what port fast feature is going to do? It first of all, it is keep listening and learning state. So immediately your interface will move in forwarding state. So यहाँ पे host को this interface, for example, मैंने यहाँ पे internet connectivity लगाई, तो मुझे तो 30 सेकंड वेट करना पड़ेगा ना यार इंटरनेट एक्सेस के लिए, क्योंकि ये इंटरफेस फॉरवर्डिंग में जाएगा कैसे, listening, then learning, and then moving the forwarding. So if you're going to enable the port fast features, the port immediately move in the forwarding state. Second benefit, it will that's this line is saying, guys, this point. Also notice the switch will not send the TCN if the port has been configured. Understood? 'So if you see over there, I'll show you this part as well. I'm just going to use this is the host over there, right? And have a look. In the previous case, if you see that, switch to right this guy. Is it my interface is up right now? So spanning tree. Hope so. Dictator/2 is up right now. There's no port fast is enabled, right? There's no port fast is enabled. And if you see, I will generate the TCN if I'm going to shut down this interface. See, because there is no port fast. And if I'm going to off this interface, how long it will take? 30 seconds, right? Listening, 15 seconds. Then it will go to the learning. And of course, then it will move in the forwarding state. Learning, good to go. $30 it will take, right? And forwarding, and again TCN generated. Topology change notification. That's not a good, right? What I can do over there as a spanning tree port fast, right? Have a look. Spanning tree port fast. H. That's it. See, the port fast has been configured on the Gigero/2 will only have effect when the interface is the non-trunking mode. The warning, the port fast should only be enabled on the ports connected to the single host. It's a recommendation. Connected to the hub, concentration switch, bridge, etc. To this interface when port fast is enabled can cause the temporary bridging loops. So it's not recommendation to enable the port fast on the trunk interface. It's only recommendation to enable on the host side. And now the beauty, if you see, show a spanning tree interface gig 0/2 detail. You can see that this interface is now is configured with the port fast. Which interface? If you see one thing, my BPD is still sent on this particular interface, right? He keeps sending the BPD. So he's sending which BPD? Configuration BPD, right? I'm talking about what TCN, right? So if now I'm going to put this interface in the forwarding state and blocking state, will I generate the TCN over there? Of course not. See, I'm not generating. No TCN is coming. Is there any TCN? No. If I up this interface, how long it will take to the forwarding state? Immediately. And will I generate the TCN? Of course not. Can you see? Am I moving the listening and learning state? No, directly in the forwarding state. Am I generating the TCN? No. So this is the beauty of this command, guys. Port fast enable. H. So you can, let me write on this command over there. You can go in the interface and see that this guy. You can also enable the port fast on a global basis as well as you need to use the command spanning tree port fast default. No, on edge default. Once I put this command, what this guy is going to tell you? Read this line again. This command is going to make the port fast only on the access port. Only on the access port. So if you have thousands of the port that is configured, right? Have a look. Better to show you now. Come on. पढ़ लो इसको थोड़ा सा मैं नहीं पढ़ूंगा मेरा मुंह दुख गया डन normally this calculation is taking between 30 to 50 seconds. I'll let you know in which way. Normally insignificant will take the 30 seconds. It will take the 30 seconds. इसको पढ़ लो यार थोड़ा सा। पढ़ लो। You can enable the port interface message and globally as well as when a spanning free port fast is enabled globally, the iOS will apply the spanning tree port fast configuration to all interface that are in the access mode. This is the line that you have to remember. Globally means what? You're only going to enable on the access mode. If you're going to enable the port interface message, you can enable on the any interface. Doesn't matter it's trunk or access. On any other interface, you can enable it. This is the line that I want to show you. Everything is good, guys. Any questions, anyone? In the insignificant topology change?
Sir, in the insignificant topology, you said it will take 30 minutes to
30
go.
seconds.
Sorry, 30 seconds to go for forwarding.
Yeah, that's a listening and learning step, no? Listening and learning.
Yeah. In that sense, like port fast is enabled, right?
If the port fast is enabled, then it will meet in the millisecond. It will comes up. It will not take the 30 seconds. Let's go. Port fast command default does not affect the port that is configured as string. So ये only किस पे affect करेगा? Access port पे. तुमको अगर trunk पे चलाना है, तो you can use this command. Spine port fast trunk. रिकमेंडेशन बहुत कम होता है जहां पे तुम नॉर्मली पोर्ट फर्स्ट ट्रंक कहां पे चलाओगे तुम देखो एक सेकंड लो जहां पे तुम्हारा सर्वर लगा हुआ वहां चला दो ट्रंक जहां पे तुम्हारा राउटर लगा वहां चला दो वहां भी तो ट्रंक बनाओगे ना वहां चला दो क्योंकि सामने वाले स्विच पे तो स्पाइन थोड़ी चल रहा है सामने वाले राउटर पे तो वहां तुम यूज कर सकते हो यू कैन यूज इट नाउ shall I take a 10 minutes of break that will be good right I think so because I need a one more hour is it fine everyone let me know 10 minutes break for this one and this one or shall I continue बोलो देखो I'll first tell you one just two just three now to understand the concept of the thing like okay now guys have a look the direct topology change or indirect topology change see if I talk about the common like the central point or we can say the common what we call over there centralized point you have to think this kind of topology change right now right now I have a block put right now I have a block put over there can you see that this is the block put okay so I told you that the topology will be changed it will the sometime it will be the 30 second and it will see sometime to the 50 second right your max is your 20 second okay the max's time is just going to tell you how long right a MAC address information will be stored on a interface On an interface in the sense of what? Not we can say that how long a MAC address information will be stick interface in MAC table. Because we are learning the MAC address on interface, right? So how long? That will be a 20-second max to max. Now understand this case. Right now, this is the blocking port. So my logical topology will, the packet flow will look like this happen. What happened if this link goes down? If this link goes down, this interface will take the, it will go in the, because what, how the state is happening. If you see the states right now, we have a disable, right? Then we have blocking, and then we have a listening, and then we have a learning, and then we have forwarding. This is how the steps is happening, right? So if this guy is a blocking state, how long it will take? 30 seconds, right? In which case, this is called as a direct topology change. Why I'm going to call this guy as a direct topology change? Because this switch, right? This switch immediately feels, hey, something had changed in my network. Because this switch has a blocking port, and blocking, it will directly move in the listening and learning. So this switch immediately feels that, okay, the interface goes down. I need to put this interface into the blocking forwarding state. It will take the, it is called as a direct topology change. How much time it will take? 30 seconds. Whereas if I talk about now this link, if this link goes down, what happened? How long it will take? 20 seconds, the MAC, how long a MAC address information will stick on the MAC address table. So right now, if this link goes down, what happened? Non-root bridge lose the information, or we can say that non-root bridge. So if the non-root bridge lose the connectivity with the root bridge, what happened? Non-root bridge will inform to another switch, hey, I'm your daddy. I'm your root bridge. And this kind of BPD, right, is known as inferior BPD. Why I'm going to call that as an inferior BPD? Because this BPD is not a best BPD. So try to understand in this case what happened if this link goes down. Switch to, right, lose the connectivity with the root bridge, and it will assume, hey, I'm the new root bridge. What happened? This guy said, hey, I'm your daddy. I'm the new root bridge. But still, switch 3 has a connectivity with the root bridge, because switch 3 know that, okay, this guy has a MAC address A, this guy has a MAC address B, so lower is this guy, so this should be a root bridge, right? But he's telling that he's, hey, I'm the root bridge. So what switch 3 will do? It will wait for the, it will put this interface, right? It will keep receiving this, it will send us, keep sending the packet to the switch 3, and switch 3 will wait for the 20 seconds. Once the 20 seconds expire, then it will move in the which state? Listening, then learning. Total, it will take the 50 seconds. This kind of topology is known as a indirect topology change, because the switches need to wait for the 20 seconds. And in the indirect topology change, how long I should wait? 50 seconds.
Law, can you repeat that point?
Of course, why not? Right? What happened if this link, read this line again? If non-root bridge, this guy will lose the connectivity with the root bridge. So what they will assume, hey, I'm the new root bridge, and it will send the BPD to this guy. He's telling this one, hey, I'm the new daddy. Which MAC address I'm sending? B. And this guy's a MAC address. So switch 3 already have a connectivity with the root bridge, right? So what switch 3 is saying, hey, I already have a connectivity with the root bridge, and he is the root bridge. So what switch 3 will do? It will not going to entertain this all BPD till 20 seconds. Still, this interface will be in the blocking state. It is not, switch 3 is not going to entertain this BPDU for the 20 second because my max is in what, 20 second. Once the 20 second expire, then the switch 3 will move this interface into the listening, then learning, and then forwarding. So how much time? 20 either or 30 either. 50 seconds. So indirect topology will require the 50 seconds to convert the stable unstable network to the stable network. Whereas if this link goes down, this link will take the 30 seconds. If this link goes down, this will take the 50 seconds. So normally this timer is a huge, right? In the insignificant topology, what happened? We had a concept of the span keyboard fast, right? And by using this thing, what happened? Now I have to skip the listening and learning state, and my interface immediately move in the forwarding state. Same thing we can do with this guy. Same thing we can do with this guy. Can you see that? If this link goes down, link failure will happen. First number. Second, switch A needs to send a TCN to the root, but it is the already a root, right? So what happened? Second or third number. First, second, the switch C send the TCN toward the root, but he can't because this link is down, right? So what happened? Root will send the configuration video with the TCN, right? Once it will receive, it will send the TCN from here. And what happened? This interface will receive a superior BPU, right? From the switch B. And what happened? This interface will take the how long? 30 seconds to move this interface into the forwarding state. This is called as a direct topology chain. But again, it will require the 30 second over there, right? If you have a look, I'll do one thing. Switch 1 right now, if you see that this is the root bridge, this spine tree, RB root bridge, and switch 2, if you see, this is non-root bridge. And my this interface is 0/0 is a root forwarding state RP. And switch 3, my E0/0 is an alternate blocking state, right? That's this guy E0/0. And my this E0/1 is a root port. If you see debug spine tree events, or we yes, and debug spine tree. First of all, you will do one thing. Interface range E0/2 to 3, then each 1/0 to 3. 2 1 minute एक चीज मुझे करने दो. So if you see debug spine tree events, right? Debug spine tree switch state. If I'm going to lose this information, right? Have a look. This interface will take the 30 second. Interface E0/1 start down. 30 second. This interface immediately blocking to the listening, right? Listening. Blocking, it will be listening, then learning 15 second. And then it will go for the forwarding state. Forwarding. So it means that till 30 seconds, this PC and this PC cannot communicate to each other, right? This is the bad, right? 30 seconds is a huge time, because in a 30 second, if you just have a look, the small glance, 30,000 millisecond is happening. And for the voice traffic, 150 millisecond is that's a recommendation, not recommendation, it's a maximum delay. If you're beyonding that, you're losing some packet. How much packet you're going to drop the voice traffic? So huge, right? For the 30 second, you don't have a communication. And nowadays, if you're not going to, like, if I'm say the hello on a phone call, and if you're not giving the reply within a 10 second or 5 second, I will make a recall, right? So what I can do, I'm going to enable the one feature that is called as a on a switch 3. Let me make a no shutdown right now. So now this interface has moved in the blocking state, and this E0/1 will go in the listening. Of course, now this is everything is fine. Then learning, and then forwarding. So E0/0 is listening, E0/has moving the blocking, E0/1 is learning, and then it will go through the forwarding state. All awesome, right? Now, what I can do over there, I'm going to enable the span tree uplink fast feature, right? And what this guy is going to do, first of all, if you put the enter over there, spine tree uplink fast, what this feature is going to do, it convert your 30 second into the how 1 second, right? Within a 1 second. But before he's going to do that, what this guy is going to do, this guy will convert your the BRIS priority 49152. So default is what, 32768. It will convert to the 49152. Why is it the 49153? It's a VLAN number. At the same time, your cost will be increased to the 3000. So default is 100 on this particular link, and it is added to the 3000. The reason is doing this thing, guys. The reason is I'm going to add to this thing. One, priority will increase 49152, right? And after that, you can add the VLAN number, whatever the VLAN number you have. At the same time, cost will be increased to the 3000. The reason is going to do that so that switch 3 will never become root bridge, and switch 3 will never comes in transit path. This command is recommendation, the spanning tree uplink fast. This command is a recommendation to enable, right, access layer switches. ये recommendation है, ऐसा नहीं है enable तो कर ही सकते हो, but it's recommendation. And what this guy is going to do, it convert. Now if you see spanning tree uplink fast, do so spanning tree summary. What happened? This spanning tree has enabled uplink fast for the all VLANs, right? And now if I'm going to shut down this interface E30/1, how long it will take this interface? Immediately. Just because the spanning tree uplink fast, move forward in the forwarding state. E0/0 is moving the forwarding state. So do I need to wait for the long time? No, of course. This is the beauty of uplink fast. So the user are sitting behind this guy, right? Data traffic will not affect over there. So my topology will converse within a second. Uplink fast is a Cisco provided feature that improve the convergence time when there is an uplink failure. This feature is designed to run when the local switch has at least, पढ़ो इसको, तो मेरे पास था alternate port एक, ये बोला, मैंने इसी पे enable किया ना uplink fast, तो यहाँ पे block port था, वहीं पे मैंने enable किया. The alternate port in the mode blocking uplink fast is the access layer solution. So this is the access layer solution. It works based on the uplink group. Uplink group consists of root port, which is in the forwarding state. The uplink fast feature is not enabled and the primary port on the access switches fails. So यहाँ पे 30 सेकंड लगा रहा था, अब यहाँ पे क्या लगेगा, 1 सेकंड, 1 सेकंड के अंदर सारा कुछ काम हो जाएगा तुम्हारा. Done. This is all over the uplink fast. इसने नहीं बताया क्या 3000 cost ये सब. It has to tell like. So यहाँ पे तुम्हारे पास एक question हो, you can have a one question, you could have, right? You can have one question like, law, what about the MAC address now? Because ये तो ये PC था, A and B, they are communicating to each other. So how they are communicating like this? So on this 0/1 interface, I'm learning the A MAC address, right? Right. Now if this link goes down and this link will be up, I have to learn this MAC address A on which interface, 0/0. So in that case, what happened? And B has to be learned on the E0/1, right? On this particular interface. So communication will happen like this. So in that case, what happened? The switches will generate the dummy multicast frame, right? The switch 3 will generate the dummy multicast frame to this guy. Hey, please update the MAC address. And in the dummy multicast frame, what happened? The source MAC address will be right, and destination MAC will be multicast. Source MAC always will be user MAC address, and the destination will be multicast MAC address. So it will send to this guy. Hey, listen, you have to update the MAC address table over there. Hello, tell me what happened. I'll call you back. So all good. And this multicast frame will send at the speed of 150 packets per second. You just update the, if somebody will ask you, right, in the interview, normally this kind of question they are not asking because these are the legacy technology. I'm just teaching you, like, maybe someone asked you in an examination, not examination, interview. That's why I'm teaching you this thing, but we are not using this technology in the market right now. Okay, if somebody is using, then suggest them, you should update the things, because these are the normally we are not using. So if somebody will ask you how the MAC address table will be updated, tell him dummy multicast frame will be sent, right? And you can see that this dummy multicast frame like this. Source will be, this is the user MAC address, and this is the user MAC address. This is the user, right? Source will be user MAC address, and destination will be multicast MAC address. To inform to the switch to, hey, learn this MAC address on this particular interface. This is how the MAC address table has been updated in the uplink fast feature, guys. Any questions in the direct topology change? You just need to remember this thing, right? What is direct topology change? How long it will take? And what is the use of this guy? The priority and this cost. And how the MAC address table has been updated just because of the dummy multicast frame. Switch 3 will send dummy multicast frame, where source will be user MAC address and destination will be multicast frame. Guys, questions? Any questions, anyone? Guys, anyone has questions? Again, I'm repeating, you don't need to read in so much detail. I already taught you this part. You just need to remember what is topology change, right? Or direct topology change, and how we can overcome this problem. That's it. That is the enough information, because these are again legacy technology. Done. Now, if I talk about the indirect topology change, in this case, what happened? Let me remove this command. I'll make the everything normal, no shutdown. So once I remove it, your priority will be comes to the default behavior. Everything is normal right now. If you see the indirect topology change, how it will take the 50 seconds. Wait for some time. Let them comes up in the forwarding state, right? Then we'll see how it will take a 50 second. Okay, so now come to the sys2. And if you have a look, I'll just going to enable something over there, debug spanning tree events and debug spanning tree switch state. And I'm to shut down this particular link, guys. What happened? Sys2 will lose the connectivity to the root base, and it behave like, hey, I'm the new daddy, right? And he will inform to this person, hey, I'm the new daddy. See, shut it down, this interface. And if you do so spanning tree, what happened? Hey, I'm the new root bridge. He's also root bridge and he's also root bridge. Is it possible in the single spanning tree? No. And what he's telling this person, he's telling, hey, this is the inferior BPD. Swiss 3 saying that, hey, I'm listening, right? Swiss 3 saying that I'm here. This guy is the root bridge on this particular interface on the blocking state. It's not possible because I already have a connectivity with the root bridge. So this guy will wait for the 20 seconds. After that, what happened? This interface will move the listening state. 10 BPD, right? 20 second. 10 into 2, 20 second. And then listening, then learning, and then forwarding. 50 second it will take, right? If the indirect topology will happen. See? $50. And after that, the switch2 will get to know that, okay, hey, already the 100 is the, previously it was saying that, hey, I'm the root bridge. Now, after the conversion will happen, switch2 will get the idea, okay, mera baap koi aur hai. Understood? To avoid this problem of 50 second, we have an ability to do that. Let me do one thing. Let me up this guy now. We have a feature, something called as a spanning tree backbone fast. This feature you have to enable on every switches, including the root bridge as well as. But this features you have to only enable on the this switches where we have blocking ports. And what this guy is going to do, it convert the 50 second into the how 30 seconds. So it is just going to reduce the max's timer. Done. How? Have a look. Gonna switch one. I'll say that, hey, listen, I have to enable this spanning tree backbone fast. I have to enable this spanning tree backbone fast. And after enable the spanning tree backbone, you can enable this features on any layer of the switches, right? The uplink fast is recommendation to enable on the access layer. You can enable on the any layer. So you have to enable on the every devices. Now, if you see, if I'm going to down this interface again, immediately, right, I will reduce the maxes. Interface, I no need to wait for the 20 seconds. Shut down. And if you see do so spine free, what happened? I just hear one BPDU from this guy. Hey, I'm the root bridge. What happened? Immediately the switch 3 will send the which message? Root link query. Hey, are you there? It just root link query means I'm asking to you, are you there or not? He will give the reply. Yes, I'm there. Root link reply. Root link query and root link reply. And once the switch 3 will get to know that, hey, switch 1 is present, my bridge, root bridge is present, what happened? Immediately this interface 0/0 will move in the listening state. No need to wait for the 20 second, the maxes. Previously, if you see, I was waiting, right? Waiting. And then I'm moving this port in the listening state. Now, no need to do that. See the difference from here to here. Listening, just receive the one BPDU. I will call to this person, hey, are you there or not? He will reply, yes, I'm there. Put this port into the listening state. No need to wait for the 20 second, the max's time. So I'm just reducing the 20 second. Now hope you will get the idea why do we need to enable the backbone fast feature on every switches so that they can understand these packets, right? Root link query and reply. And based on that, they will take the 30 second, right? That is the called as a backbone fast. It's not showing the info of being fast and backbone fast. And you can verify this feature as well as on switch 3 and go ahead and check it. And we can see that is enabled. So every BPD, right? So he's saying the number of inferior BPD received 1 because he has sent the one BPD. Can you see that this video? Because he's sending the inferior BPD, right? Of course, he's telling that, hey, I'm the root bridge. But he will ask with the, hey, are you there with the root link query? He will give the reply, yes, I'm there. So only one root, I'm receiving the inferior. So he's saying that, hey, I'm only receiving the one inferior BPD. Absent the, root link query one is not sending the reply packet showing that over there, but they have a reply packet as well. Again, guys, these are the not recommendation solution to use it. This feature, right? This feature, which are the feature? I'll tell you. Both fast, uplink fast, and backbone fast. These three features we are just introducing, or we can say that the reason, the reason to use this feature to make a PVST faster. The reason to use this feature to make PBST faster. This is the only thing, that's it. And normally in the production, we are not using the PBST. So do I need to enable these features? No. We are using the RSTP protocol, right? You're getting my point. We are using the RSTP protocol, not the PBST right now in these days. The reason to use this feature to make a PBST faster, nothing else. That's it. Hypothetically, if I talk about, I'm not going to calculate in the millisecond, right? Because the PBST concept comes in the second part. So I'll take it hypothetically, it will take the 1 second, hypothetically 1 second, and hypothetically 30 seconds. To make a PBST faster, we are using this feature. But right now in the market, we have a concept of RSTP protocol, or we can call as RPBST. RSTP, we'll see that tomorrow, not tomorrow, or Monday, and we have an MSTP protocol, or either we can say the MST. RSTP is a IEEE standard, RPBST is a CISCO. So both are working the same. Guys, anyone has Bhushan, Ganesh Kumar, Kavita, Prashant, Salman, Srikant, Venkat, Vinay? Do you have any questions, guys? Here I'm done with your PBST concept and the TCN. So these are the complete, if I talk about the agenda of the today class, I was completely talking about the TCN part. What is the meaning of topology change and whatever the circumstances is happen in my topology.
Yeah,
But
no,
again,
on my side.
But again, I'm telling you guys, you don't need to waste so much time on this part, topology. You just need to understand the concept, what is the meaning of TCN. So if somebody will ask you, hey, what is a TCN? TCN is a topology notification, and depend on the network topology, we have a different chains, insignificant, uplink fast, sorry, that topology change or indirect topology change. What TCN is going to do, TCN is just going to convert your MAC address aging time 300 seconds into the forward delay 15 seconds. To reason, why do we need to convert? To just avoid the black hole. And on which flag they will use? The TC flag. And who will set the TC flag? The root bridge will send the TC flag in the configuration BPD. So that topology change will take the 30 second. After enabling the uplink fast, it will take the 1 second. Indirect topology change will take the 50 second. After enabling the backbone fast, it will take the 30 second. Or insignificant topology change normally take the 30 second. After enabling the port fast feature, it will take the 1 second. Within a 1 second, it will come in the behavior, and they will skip the listening and learning state. So whatever the interface is enabled with the port fast, they will not generate the TCN. You can enable the port fast in two ways, at the POI interface basis and the global basis, right? The POI interfaces, if you're going to enable, you can enable on the in interfaces as access port and trunk port. It's not recommendation to enable on the trunk port, okay? And if you're going to enable the port fast default behavior, it will only enable the port fast only on the access port, not on the any other port. But if you're going to enable on the POI interface basis, no need to make that interface as a access. You're seeing the forcefully you're enabling the port fast over there. But the recommendation, if you're going to enable the default, the recommendation is what? The interface should be in the port fast. Sorry, should be in the access if you're going to use the default behavior. You can also use the port fast on the trunk interface only in the scenarios that I know. If you know anything, let me know as well. As I know, if you have a trunk between the switches to the router and switches to the server side, because the end devices like your router, not end devices, router and server, that's not going to support the spanning tree protocol, right? So you can enable the port fast trunk over there as well if you want. That's my complete, the conclusion part of the all those 2 hours of the classes. Anyone has a questions now? All done. So guys, here I'm done with the PBST. We'll see that RST protocol and MSTP on the Monday. Perfect. So guys, tomorrow session, ISS protocol, 8 p.m. You have to attend this batch. I'm not going to share the drive link in group, in WhatsApp group. I will share you the drive. I'll give you the drive link. It's not like that. I'll give you the drive link as well as to download the videos and see the videos. Of course, I will record the session as well as, but in the Zoom chat, because I don't want to flood this information right to the anywhere. So just have a attend the batch. ISS, it's a very good protocol in the, like, what I call, I forgetting, I'm not able to use that words, in the, like, perspective of if I going to use the SDA part, right? SDN part. Amazing protocol. Recommendation to use in the beginning. So guys, here I'm done. Anyone has a question, you can ask me.
Sir, for ISIS same link, sir. For
Yeah, of course,
Monday.
yeah, same link. But again,
Okay.
you must need to know about the basic routing. If you don't know the routing, you can't understand the ISS.
Okay, sir.
Recommendation to know the routing. All good, guys. So hope I'm clear. Bye bye. Have a great weekend, everyone. Good night.
Good night, sir. Thank you.